If you watched my previous video, then you already know what WINE and Proton are and why Windows games can even run on Linux in the first place. But now comes the real question: what actually happens when you click play? Like, what does Proton actually do? What is WINE doing in the background? Why are weird folders like System32 and SysWOW64? And why does Linux gaming work so well without emulating Windows? So in this video, we are going one level deeper into the rabbit hole, still oversimplified, but this time we are looking deeper under the hood. So with that being said, when you click play on a Windows game in Steam, Steam does not directly run the .exe. Instead, Steam launches Proton first. Proton then prepares the entire environment for the game. It loads WINE, selects compatibility settings, prepares the game's prefix, and handles Windows-specific behavior before the game even starts. By the time the .exe launches, the illusion is already in place. From the game's perspective, yep, looks like Windows to me. And we can actually prove this. If we open a system monitor here, we can see the Windows game running through WINE processes in real time. We can see the game executable, WINE, and wineserver running in the background. Now, if you don't know what a wineserver is, it's basically the manager process behind WINE. It helps Windows applications behave correctly on Linux by coordinating processes and communication between programs. One of the biggest misconceptions about WINE is that people think it's emulating Windows, but that's actually not true. WINE is not emulating a CPU. It's also not running a virtual machine. The game's instructions are executed natively by your processor. Your CPU doesn't care whether code came from Windows or Linux. Instructions are just instructions. What WINE actually does is something much smarter. It re-implements the Windows API. So when a game says, "Hey Windows, open a file," or "create a game window," WINE intercepts those requests and translates them into something Linux understands. So the flow looks something like this. The game thinks it's talking to Windows, but Linux is doing the real work underneath. And because this is translation instead of full emulation, performance can be extremely fast, sometimes even comparable to Windows itself. Now, to understand the next part, we need to talk about DLLs. On Windows, programs rely heavily on DLL files. DLLs are basically shared libraries that contain functions games and applications depend on. Things like graphics, audio, input, networking, and file management. Games constantly load DLLs such as kernel32, user32, and d3d d11.dll. On real Windows, these come from Microsoft, obviously. But on Linux, WINE ships its own versions instead. These WINE built-in libraries behave like Windows libraries on the outside, but internally they translate everything into Linux behavior. But here's where things get even more fascinating. Sometimes WINE's built-in libraries work perfectly, sometimes they don't. Certain games expect specific Windows quirks, exact library behavior, or even old bugs from Windows itself. Or maybe you're trying to run a heavily modded game, and this is where DLL overrides come in. What you're seeing here are DLL override settings provided inside WINE. They control whether a game should use WINE's built-in libraries, native Windows libraries, or a combination of both. Sometimes changing a single DLL override is enough to completely fix a game. This is also why tools like Proton Tricks and WINE Tricks exist. When people install things like Visual C++ redistributables, DirectX components, or even .NET frameworks, they are essentially giving WINE additional Windows libraries the game expects. And honestly, Sometimes changing a single DLL is the difference between a game launching perfectly or crashing instantly. Now, if you have ever explored a WINE prefix before, you have probably seen two strange folders, System32 and SysWOW64. And yes, the naming is completely cursed, because on 64-bit Windows, System32 actually contains 64-bit libraries, while SysWOW64 contains 32-bit libraries. No, I'm not even joking. WINE mirrors this exact structure because many Windows applications expect these folders to exist. When a game launches, WINE reads the executable and immediately knows whether it's a 32-bit application or a 64-bit one. From there, 32-bit programs load 32-bit DLLs, and 64-bit programs load 64-bit DLLs. This is why both folders exist inside the prefix, because even today, many launchers, installers, and helper applications still rely on 32-bit components. So WINE maintains both environments at the same time to keep the compatibility working. And honestly, the deeper you look into WINE and Proton, the more fascinating they become. Linux gaming doesn't work because Linux magically understands Windows games. It works because developers spent decades carefully recreating just enough of Windows to make games feel at home. So there is no virtual machine involved, no Windows kernel involved, and no full emulation involved. Just translation happening in real time, compatibility layers, and a lot of engineering magic. And the craziest part is, most games have absolutely no idea Linux is underneath all of this. Except games with kernel level anti-cheat, of course. They just assume they are in a Windows environment when they are not. So if you enjoyed this video, drop a like, comment down below if there's anything I missed, and let me know how deep you want this series to go. So with that being said, it's your boy Jury, and I'll see you in the next video. Take care.